Uh, Rick was having some technical issues, so we've decided to switch sessions. He's gonna do his session later, and I'll do my session now. So this session is practical version control using Git and GitHub in your daily work. My name is Doug Henning. I'm a partner with Stonefield Software. The next two slides just kind of tell you a little bit about me, but basically it's just a long way of saying I've been around for a long time and I've done a bunch of stuff. So I won't bother going through the details. Um, Version control, which is also known as source control, is an essential part of modern development. I'd actually even characterize that a little bit more and say modern professional development, because really to be a professional software developer, version control is really kind of an essential part of your toolbox. There were older version control systems. Visual Source Safe was a well-known one that were kind of different than the way tools work today. Typically, there was a single repository where you would check in or check out files from, and they were really kind of a pain to deal with as a result. Git is a modern version control system, sometimes called a distributed or DVCS, distributed version control system. The idea is that every developer has their own local repository. There is a central one as well that we'll talk about in a minute, but every developer has their own local copy of the repository in a .git folder. There's no check-in or check-out. You make changes, you commit them, you deal with any conflicts. You deal with the remote repository, but basically it's distributed. GitHub is a remote repository platform. It provides a common location, so it's a remote repository for your applications. And developers work with it by, first of all, cloning it, so that creates a copy of it on their machine. And then they'll pull changes from it or push changes to it. Git is command line based, but we're not going to talk about the command line at all. I'm not going to be doing anything from the command line because, again, we're modern developers. We're not going to be doing things back in those days. I know a lot of developers like to use Git from a command line. I don't personally, so I'm going to show you the way that I work, and we're going to be talking about graphical tools as a result. So first of all, to get started, if you're already using Git, then this will be a bit of a review to you, but maybe you'll find some new things in it. And of course, if you are not using Git, this will be new to you. So first step is to install Git. And by the way, I'm not going to go over how you do these things. The white paper goes through them in detail and talks about some configuration things, some questions to some of the answers to some of the install questions you may be asked. So I'm not going to bother going over that. I'll just point out a few highlights here and there. So first thing you'll want to do is install Git. It comes in either 32-bit or 64-bit versions. You can install the 64-bit version. And like I said, there's a couple of little tweaks in there that you'll want to make. One of the configuration changes you'll want to make, though, is to make it file case insensitive. We'll talk about VFP's weird casing rules later on. But if you don't make it case insensitive, it'll kind of drive you crazy. Git was created for the Linux world initially, and so and Linux is a case sensitive operating system, whereas Windows is not. So you'll definitely want to configure Git to be case insensitive. The next thing you'll do is install Tortoise Git. You'll install the same bitness that you install of Git. So if you install the 64-bit version of Git, you'll install the 64-bit version of Tortoise Git. I will show you a couple of configuration changes that you'll want to make, though. So let's just go here. And once you've installed Tortoise Git, it installs into the File Explorer shortcut window. So you'll see that there are functions that we'll be using this a lot. So we're going to go to Tortoise Git and then Settings. And a couple things you'll want to change. You'll want to go to Advanced. And if you scroll down the list here, you'll find Overlays Case Sensitive. You'll want to change that from True to False. Tortoise Git adds overlays on top of file icons. They kind of look like this. They kind of look like this. So for example, a file that has not been changed will show with a green check mark. A file that has been changed and not committed yet will show with a red exclamation mark. So Tortoise Git gives you those icon overlays. However, by default, it's case sensitive. So if it has an uppercase, capital S, capital C, capital X, and it's checked into the repository as small s, small c, small x, those are different as far as tortoise Git's concerned, unless you make it case insensitive. So you'll want to do that. A couple other things you might want to do. I find that having the default status cache, I find that setting shell extended works just a little bit better for me. You may want to, try it out at the default setting. And then if you run into any issues, try changing it to shell extended. The one downside for using shell extended is that it doesn't refresh immediately. Sometimes it does, sometimes it doesn't. You may find you have to press F5 in File Explorer to refresh your browser or to refresh your Explorer and see those icons changing. You can choose what icon set you want. The default is this XP style, but there's lots of other styles. There's flat and so on. So you just pick whatever style looks good to you. And one other thing to point out here is that not all overlays may necessarily appear, and you can configure certain of them. You can have it not show ignored files, not show unversioned files, not show added files. But even if you have these turned on, they may not all show. And the reason for that is because Windows only supports 15 different overlay handlers. Oh, sorry. Amber Alert. Sorry. For some reason, an Amber Alert just occurred on my phone. All right. Anyway, there's only 15 icon overlay handlers in Windows. And if we start the registry editor here, you can see that OneDrive takes up the first 7 of them. So that only leaves us 8. So basically, leaves us 8. So these first 8 will be used in Tortoise Git, but unversioned is basically going to be ignored. And it's not just OneDrive. Dropbox does the same thing if you have it installed locally. Now, you can go and remove these. You could go and delete if you don't care about Dropbox icon overlays or OneDrive icon overlays. You could delete these from the Windows registry, and then all the Tortoise Git ones would come into play instead. That's up to you to decide how you want to deal with that. All right, so anyway, the next thing you'll probably want to install is Beyond Compare. Git and Tortoise Git do come with diffing tools, difference as in tools that allow you to find out what the differences are between files. So there are diffing tools that come with Tortoise Git and Git, but they're not very good. You'll want to use Beyond Compare instead. It's cheap. It's like $35 per developer, and it's way better. And given that you'll use it a lot, it's really better to have a good tool rather than a free crappy one. So you'll want to install Beyond Compare. Now, Beyond Compare doesn't automatically work with Git and Tortoise Git. You have to configure it, and that is described in the help file about the settings that you change. In fact, the screenshot over at the right shows one of the changes that you'll make in Tortoise Git to tell it that you're using Beyond Compare. Next, you'll maybe want to install SourceTree. SourceTree is a free tool that you can use as a graphical interface for Git. I tend to use Tortoise Git, as we'll see throughout the session, more than I do SourceTree. Some people use SourceTree exclusively. You can use both. I do use SourceTree when I need to do history and certain other kinds of operations that are just ugly to do in Git or Tortoise Git. So I use SourceTree for some things and Tortoise Git for others. You may use one or the other exclusively. It's up to you. You'll develop your own style, I guess, of working. The next thing that you're going to need is a tool that converts FoxPro binary files to text files. And there are a number of these available. For example, Christoph has one called 2Fox. The one that I use, and I think lots of other developers use as well, is called FoxBin to PRG. It's a project that's available on VFPX. But before you install that, you'll want to install Thor if you haven't already. Thor is another VFPX project that is a utility manager, amongst other things. And so I highly recommend, if you haven't already done so, install Thor. Again, the instructions are in the white paper. After you've installed Thor, you'll then use Thor check for updates to install FoxBin to PRG. There are a couple of configuration things you'll want to do with FoxBin to PRG. There's a configuration file you want to tweak a little bit to control how it behaves. And you'll probably also want to add FoxBin to PRG to the shortcut menu in File Explorer, and I'll show you how that works in a little bit, but the instructions are in the white paper. And finally, another tool that you might use is Markdown Monster. Documentation on GitHub is based on Markdown, which is very similar to HTML, but it's much simpler syntax. So instead of using, bracket UL bracket, bracket LI bracket to do a bullet. You just use a dash or an asterisk. So it's simpler syntax, but it still renders similar to how HTML does. So it's nice looking text. Uh-oh, sorry. Another Amber Alert. I'm not sure what's going on today, but technical issues. Okay. Anyway, so if you want to use Markdown for documentation on GitHub, then you'll want a tool that knows how to work with Markdown. It's just a text file, so you could use Notepad or Notepad++. But Markdown Monster is, again, inexpensive tool. It knows all about Markdown and it has lots of great features. So again, I recommend that you install that tool as well. All right, so now we're ready to get started. So we're going to create a local repository. There are both local and remote repositories. Each developer on their machine will have a local repository. First question to ask is, where does the repository go? So let me show you our development environment here. I have a folder called Doug. So this is going to represent my machine. I also have another folder here called Tamar, because we'll be working with two developers, although it'll be just me. But this is going to represent Tamar's machine. So on Doug's machine, there's a folder called Development. It has App 1, App 2, and Common. If we go and take a look at App 1, it has a form and it has a couple of programs. One of the programs is from the App 1 folder. The other is from a common folder. So this is typically where you'd have library files that are commonly used between different applications. And App 2 is similar. It doesn't have a form, but it has a main program that comes from its folder. And it also references that common.prg from the common folder. And then finally, we have this common folder, which is where we have our libraries, like whether it be things like XFRX or any of Rick Strahl's WW tools or things like that that you might use in multiple applications. They're going to be in this folder here. So the question is, because Git repositories can't go up levels, they can only go down levels. So it can be, if I have a repository here, it can be this folder and any subdirectories, but it can't include any files from the common folder. So even though common.prg is part of this project, if I build a repository here, I can't have that common.prg as part of that repository. So one choice is to have a different repository for each application. I'd have a repository here, and one here. The downside of that approach is that I've got 3 different repositories. So now I have to pull from 3 and push to 3 and keep track of 3. But the benefit is they're all kept separate. So that may or may not be an advantage to you, depending on how you want to work. Another approach is to put the repository at the parent level of all of your development folders, the ones that contain your applications and your common. So in this case, that's the choice that's the one I'm going to choose this time. But again, it depends on how you want to work. So that's what we'll do is we'll create a repository at this parent level. So I'm just going to right click and choose Git Create Repository here and choose OK. And it created that repository. And all that happened was it created a Git folder. Didn't touch any of my files or do anything. It just created this Git folder. Now, although you can see it, I want you to pretend that this folder does not exist, because you're going to do nothing with it. You're not going to play with it. You're not going to change it. You're not going to look at it. You're going to completely ignore it because it's a repository and Git needs to manage that. So let's pretend it doesn't even exist. The next question is, what files belong in a repository? Just because we've created a repository doesn't mean we've put anything into it yet. So what files belong there? Typically, it's only going to be the things that are needed for another developer to start working on the project. So for example, a lot of my program folders have got x.prg and y.prg that are little test programs. You know, I want to try out something, so I'll modicom x, type a little bit of code, run it. Oh yeah, that does work. Okay, now I'll put that into my actual, my actual development code. And so these little x.prgs and y.prgs are hanging around, but they are not part of the repository. They're not part of the application, so they don't really belong in the repository as well. You can have files in folders that are in the repository, but those files don't belong to the repository, and this is an example of one of them. Another rule that we should follow is no generated files. So a PRG gets compiled to an FXP. FXPs do not belong in the repository. A menu, an MPR or a MPX, MNX, MNT files get generated to an MPR. So the MPR doesn't belong in the repository, and its compiled version, NPX, that doesn't belong in the repository only. It's really just source code that we can care about. We also don't want to have the application's data, the data that's maintained by the application, to be part of the repository, because that'll change all the time, even if you just have some test data. So really, data doesn't belong in the repository unless it's considered part of the source code. For example, metadata tables, that is source code, it doesn't get changed by the end user, that does belong in the repository. Or maybe you have a static table of US states, for example. That'll never change, ever will that change. And so, you'll probably want to include that in the repository as well. Text equivalents for VFP binary files, because we can't compare VFP binary files, or Git can't compare VFP binary files, we need to create text equivalents of those. And I'll show you that in a couple of minutes. But those need to be included in the repository as well. Documentation, for example, those markdown files I was talking about. Maybe it's documentation about what how to develop the application, or how to make changes to certain things, or how the application works, or what the tables are, or file structures, or whatever your documentation is. Using Markdown is really nice for that, because they're just text files. They can easily be compared and merged between, different developers can maintain these files, which is more difficult to do in things like PDFs and Word and so on. Other kinds of files might belong in the repository. For example, icons and other kinds of images, or maybe text files that are used for various things. Anything that really belongs to the source code itself belongs in the repository. Now, one controversial thing, though, is what about VFP binary files? Do they belong in the repository or not? Some developers say yes, and some developers say no. The people who say yes, the people who say no, they don't belong in the repository, say that's because, if you think about it, it really is reason number 2, no generated files. Because Fox bin to PRG and other tools typically are two-way tools, you could actually generate the SCX and SCT, or a VCX and a VCT, from the text equivalent. So if you can generate it, then they shouldn't be in the repository. The people who say yes, they do belong in the repository, generally have two reasons for it. One is that, what if there's a bug in the Fox bin to PRG that, for under some circumstances, cannot convert my SC2 file back into the source code SCX and SCT files? Then I'd have a problem, right? Because now I don't have my SCX anymore. And that's one good reason. Another good reason is that, if you think about it, the SC2 file really isn't source code. We're never going to work on it. The only reason we have it at all is so that Git can do comparisons between different versions. It's not source code. The SCX and SCT files are source code. Those are the ones that we actually work on. So typically it depends on the project. Some projects I do and some projects I don't. But a lot of developers include the VFP binary files in the repository for those 2 reasons, and maybe other ones as well. All right, so let's go and add some files to our repository. So I'm going to go up to here. I'm going to right-click, and I could add the files individually, but you could also do them sort of en masse. So we'll just go to tortoise git add. And remember, I don't want FXP files, so I'm going to turn off that one, and this one, and this one. So I'm going to, and this one. So I'm going to add these files to my repository, and they're now added. The next thing I'm going to do is I'm going to commit them. Just because they're in the repository doesn't mean that I've actually put them in the repository. I've really just, at this point, staged them. I've expressed my intent to put them in the repository, but at this point, I haven't done that yet. You do that by committing. So I'm going to right-click, and you notice that the message here is git commit to main. We'll talk about that main in a little while later on. Anyway, so we're going to git commit. You need to enter a message of some kind. The message can be anything you want it to be. Typically, the tradition is that for your first commit, it's initial commit. So we'll say initial commit, and it's going to put these files in the repository. You can see these files are not going to be in the repository. So let's choose commit and close. And now, if you go and take a look at the folder, you can see there are green check marks beside all the files that are in the repository and are unchanged. And depending on how I have Git configured, there may or may not be a blue exclamation mark or a blue X on files that are excluded. In this case, it's not showing that, but because there's no overlay, that's kind of my hint that this file is not included in the repository. And of course, I've got these files and I've got these files here as well in the repository. All right, so next is that, as I mentioned earlier, we need to have text equivalents for our binary files. And there are several ways that you can generate them, assuming that you're using, say, Foxbin to PRG. But even with that, there are several ways you can do it. If you're using Project Explorer, which is a replacement for the VFP Project Manager, it's a VFPX project, it automatically generates text equivalents. So if I open up a form, make a few changes, close it, Project Explorer automatically generates the SC2 file for that form. Another alternative is you can do send to. So if you've configured Foxbin to PRG, which is described in the white paper, how you do that, then it'll add some functions to the File Explorer shortcut menu. So for example, I can go here to my SCX file and my PJX. You can select multiple files. Oops, I want my PJX and my SCX. I'm going to right click and choose send to Foxbin to PRG binary to text. So I want to convert the text equivalents of those two binary files. And when it's finished, I have a PJ2 file, which is the project, and I have an SC2 file, which is the form. And if I take a look at this real quick, here is what that SC2 file looks like. It's readable. I mean, it's not runnable. It looks like VFP code. It's not runnable, but it does, it does show you what that form looks like. All right, so now, let's go and add those two files to our repository. So I'm going to choose Tortoise Git, add, okay, and they're now in our repository. Another way that you can do it is using Thor. Once you've installed Foxbin to PRG using Thor check for updates, then Thor knows about that. So if I go into VFP for app number 2, I can go to Thor Tools, Applications, Foxbin to PRG, Projects, and then convert all binary files to text files. So now we're not doing it individually. It's going through the project and all binary files included in that project. I use this feature all the time. So I've actually assigned a hotkey to it as Alt-1. So if I just hit Alt-1, we see a window kind of came up quickly and flashed, and then it went away again. That's the Foxbin to PRG window. Anyway, let's close this. And we'll see that now we do have our PJ2 file. Let's go and add that one to the repository as well. And now that we've added those files to the repository, we have to commit those changes. So we go to git commit, and we'll say added text equivalents. Now you'll notice, by the way, that those unversioned files still show up here, and they're going to keep up showing up all the time. And I'll show you in a second how you can avoid that. Anyway, so we're going to add those text equivalents. We'll commit that change. And we're done there. As I mentioned earlier, VFP has some weird casing rules. And so you might find, for example, if you look at the image over at the right here, initially the form was called test.scx and sct in lowercase. But after I modified the form, VFP changed them to uppercase. And so, again, this is another reason why you'll want to configure both Git and Tortoise Git to be case insensitive, because you notice it shows in this image here, it shows as no overlay. So you might think that those files are not included in the repository because at the time I took the screenshot, I specifically turned off case sensitivity or case insensitivity. So just to be aware of that, you might see things like in the repository, this file was initially in uppercase, but now it's in lowercase because that's what Foxbin to PRG does. It automatically puts the extensions into lowercase. But because we have a case insensitive, that's not something we're going to have to worry about a whole lot. One other thing we might want to do, though, is to get rid of or to ignore those files that are excluded from the repository, like this FXP file. So if you right-click that and choose Tortoise Git, add to ignore list, and rather than this specific one, we actually want all FXP files. We want that to be recursive, so not only this folder, but all subdirectories. And what that did was, at the root level for the repository, it created a file called .gitignore. And if we take a look at that file, it really just has one line in it, star.fxp. So it's going to ignore all FXP files. Now, there's other kind of files you'll probably want to ignore as well. Christoph Vollenhaupt has a, oops, I'm going to go here. Christoph Vollenhaupt has a repository on GitHub, and I've got the link to it in the white paper, that has a sample git ignore file that includes typical files that you'd exclude for VFP applications. And so I actually took that file and just made a couple of little tweaks to it, and it's included with the samples for the downloads for this session. So I'm going to take this git ignore file and we'll overwrite this one, and let's just take a quick peek at it. So it ignores not only FXPs, but also MPXs and QPXs. And you notice that it'll be all forms of the case, whether it's a capital FXP or a small FXP or whatever. Same thing with ERR files and BAKs and TBKs and MPRs and underscore command.prg and Fox user and so on. So all kinds of different files that it automatically ignores. So that's why I typically start a project with this file in my root folder. So we'll want to add this to our repository. So let's go and do that. And again, we'll do a commit. And this time you'll notice there are no ignored files, because the only files that are not in the repository are those FXPs, and it knows it's supposed to ignore those. So we'll say we added .gitignore, and we'll commit that. Any questions at this point?
Lots of discussion, but I don't think anything that's actually a question for you.
Okay.
Oh, there was one actually way back. Can you give one example of a big advantage of Beyond Compare versus the built-in diff tool of Git?
All you have to do is see it. The user interface for the Git diff. Let's see. I don't know if I can. Let me just see if I can bring it up. I don't know that I can, because I've got it. I've got it configured so that when I bring up diff, I get Beyond Compare. So I'm not sure I can bring up the Git diff tool. I guess I could by going to the command line. But basically, the UI is way uglier. It doesn't have as many features. It's just, like I said, try the one, like before you install Git, or before you install Beyond Compare, just try and take a look at the one that Git comes with, and you'll see exactly what I mean. We'll be looking at Beyond Compare in a little while, and like I said, you'll recognize immediately that there are big differences in features and appearance. All right, so now we have our local repository. We've added files to it. Now it's time for a remote repository, because Tamara is actually going to be working with me on this project, so she needs to be able to grab the files that I've been working on so that she can start working on it as well. So we're going to start by creating a repository on GitHub. There are other platforms you can use. For example, there's Bitbucket and others as well. GitHub is probably the most popular one, and so that's the one that we'll stick with. We're going to configure our local repository so it knows about that remote repository, and then we're going to go and do a push to actually send those files up. So let's go to GitHub. Oops, let me open my browser. And let's go to GitHub. It automatically logs me in, but of course you'd have to have an account. So there you can create a free account for certain types of projects. I think the development team less than 5 people or something like that. Anything more than that, you'd have to have a paid account. But assuming that you're a small team, you can create a free account, and then you can go and create a new repository. So I'm going to create it called VFF test, and it always creates it under whatever if you've logged in as an enterprise account, it'll create it under that enterprise account. I'm logged in under a personal account, so it creates it under my personal account. You can specify a description for it. it could be public. In this case, we probably want it to be private because this is not something we want everybody to have access to. This is our own, this is applications that we develop for a living. So we don't want to have anybody have access to our source code, just the people that we say that can. So we'll make it private. We're not going to bother with anything else. I'm just going to go and create a repository. All right, so here's my repository. There's nothing in it yet. It's empty. So one of the first things I'm going to do, though, is I'm going to invite other people to work with this repository. So I'm going to invite collaborators. You're going to have to click there, or you can do it through the settings. And of course, this is one of those things that requires extra security. So it's going to have to kind of log in twice. It's using a passkey. Anyway, so I'm going to go down here and I'm going to add people. Now you need to know the GitHub account name for the people you want to add. I happen to know that Tamar is Tamar E. Grainer. Oops, got to spell it right. There we go. So there she is. So I would click her. Now I'm not going to do it just because she doesn't need to get an email for a repository that's going to be gone in an hour. So, but normally I would click on her name. I would then click add Tamar. It would send her an email with an invitation. If she clicks the link in the email, she then gets added as a collaborator to the project. And you can have, whatever number of collaborators you're allowed for your account. Anyway, so the next thing I'm going to do here is I need this URL because that's the URL for the repository. So I'm just going to click this little copy button right here. Then I'm going to go to my repository and I'm going to right click and I'm going to choose Git Sync. Now at this point, if I try and do a push, it doesn't know anything about that remote repository. I mean, how would it? I haven't told it where it is. So I'm going to go here to manage and you notice that it shows me this big hint. This is where you put in that URL. So I'm just going to paste it now because I copied it earlier. And I'll choose OK. And now I'm going to do a push. And it just asks me, is this the branch you want? I'm going to say yes. And it goes through and it was successful. And if we go back to my repository and refresh, now we see that it has the exact same content as my development folder does. There's app 1. And there are the files in the app 1 folder. There's app 2 and common, and there's my git ignore and so on. Now, by default, GitHub will show the content of a README file. And so you'll probably want that. It's kind of like the home page, for your application. So let's go and create one of those. I'm just going to create a text file. Oops, new text document, and it's readme.md. And I don't think the case is that important, but the standard is that it's capital README and small md. Anyway, let's go and modify that file. I'm not going to put much text into it, but this will briefly show you Markdown Monster, which is a great tool if you're doing Markdown stuff. So this is how you do a heading. Instead of, bracket H1 bracket, you can just say, hashtag. That's my heading level 1. So applications. And you can see that as I type, it eventually renders it over at the right-hand side to show you what it would look like. 2 of these is like an H2. So this is app 1. App 1. And this is app 2. And I want to put a bulleted point in here like feature 1. Oops. Feature 1 and feature 2. Oops. Fingers really aren't working well today, are they? Okay, feature 2. And so you can see over at the right, that's how it's going to be rendered as Markdown. So let's save that. And let's go and add that to our repository. We'll commit. And now we're going to do something new, which is we're going to push into the repository. However, I want you to get in the habit of not pushing. You pull, then push. Because you don't know, for example, if other people have made changes to the repository. So our normal operation is going to be do a pull first, see if there were any changes. There's no in change list tab. If there was an in change list, that means that somebody else made some changes that got pulled in. But there isn't, so I can just go and do a push right away. Okay, and again, it was successful. And if we go back to GitHub and refresh, there is my page. Now, of course, these can be links. It doesn't have to be one big document. You can have hundreds of pages of documentation linked just like you would in HTML. And so that's, like I said, it's a great way for documentation for your project. All right, now Tamara's ready to start working. So let's go to Tamara's machine. It's really just a folder on my machine, but we'll pretend this is Tamara's computer. So what Tamara's going to do is she's going to right click and choose Git clone. And she's going to go and paste that same URL in. So she's going to go to, I'll have told her where the repository is. So she's going to go to the repository, or I can just give her the URL. But either way, she's going to go and grab that URL, and then she's going to paste it in. Because I already had it on the clipboard, it pasted it in automatically. But anyway, that's fine. Now, we don't want to put it into the VFF test folder. By default, it's going to put it into the same folder name as the repository. I want to use the same development structure as Doug, and so I'm going to put it into development instead. So it does the clone, it pulls everything from the repository, and now you can see that we have the exact same development structure as Doug has. So there's app 1, app 2, common, we see our git ignore and our readme and so on. All right, any questions about the remote repository?
We're asked where are GitHub servers located. Oh, but that actually got answered anyway.
Okay.
But I think that's it. As I say, a lot of discussion, but no questions.
I'll be interested to read that discussion later on then. So, all right. So now let's talk about a simple workflow. We're going to be doing this workflow a bunch of times, and this is basically going to be how you work. Now, it's a little bit different than if you're not using Git. Obviously, you'll make changes, and that's probably the only thing on this slide that you would do if you're not working with Git or GitHub. But this is going to be our workflow. We're going to make changes. We're going to generate the text equivalents for any binary files that we change. If it's just a PRG, then that step would get skipped, but we will generate the text equivalents. We'll commit. We'll pull. We'll deal with any merge conflicts, if there are any. We'll talk about that. And then we'll push. So we're going to use this cycle over and over again. Make changes, generate text files, commit, pull, deal with the merge conflicts, push. So let's go and start working. We're actually ready to start doing something with our application. So let's go on Doug's machine. We're going to go into our project, and we're going to open up a form, the form, there's only one. We're going to add a button. We're not going to put any code in it. I'm really good at adding buttons, not so good at filling in the code. So we'll go and save that, and we'll quit. We're going to generate the text equivalent. So I'm going to right click, send to Foxbin PRG, and there's my updated file. And now we're going to go here and we're going to commit, added button. Please use more descriptive commit messages that I'm using. I'm trying to keep it short. You don't have to watch me painfully type, but more descriptive messages are better, such as implemented change request number 5, blah, 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 that kind of thing. More descriptive messages, the better. Anyway, we're going to commit that, and we are going to pull. Nobody else made any changes yet, and we're going to push. All right, now, in the meantime, while I'm working on that, Tamara goes and she's also working on the application. So she goes into the main program, and you know what? This is actually a kind of a cool application. So let's go and change that message. Let's exit out. Now you notice we don't have any binary changes. Well, we sort of do. That PJT file got changed because the home folder got changed. So I can go and do this. I can go and generate the binary file, the text file for it. But you notice the text file doesn't change. Foxbin to PRG is smart enough to not write to the file unless something actually changed. And you can configure it, which I've done, to not put that home directory into the text file. So that way, things like that don't cause a change to the file. Even though the PJT file, it's different, the text equivalent is not. Okay, so let's go now and let's commit our change. Change the message. Commit that. And we're going to sync. We're going to do a pull. And oh, there is something on the in change. Let's go and see what it is. Okay, so test.scx and sc2 were modified, but I can't really tell how because they're binary files and it's really hard to compare. But the sc2 I can. Let's go and find out what happened here. I'm going to right click and choose compare revisions. And oh, I can see right here, Doug added a command button to the form. It shows up in a couple places. This object data is used for Z order or Z order, as we say in Canada. But the real change here is that a command button was added to that form. Okay, that's no big deal. We know about that. And let's go and do a push and send our changes to the repository. And if we go and open up our project now, Tamar opens up the project. There's the button that Doug added. Okay, so Tamar now has the changes. Oh, sorry, let's go back in there. Let's go and add, Doug is good at adding buttons, but not so good about filling them in. So let's go and add some code here. Let's say testing. Okay, and let's go and now rather than generating those files individually, those text files, I'm going to use my Alt-1 hotkey to go through the entire project and regenerate any text equivalents for any files that got changed. And we can see here that test.sc2 did in fact get changed. So let's go and commit our changes. Remember our cycle, modify, commit, yada, yada. So we're going to say that we added code to button. We'll commit that. And we're going to sync it. Do a pull. No other changes were made. We're going to do a push. Now, by the way, you'll notice that it still shows a red icon. That's because of the way I've got Git configured. If I press F5 to refresh my browser, it turns green. So I could do that right away, but sort of it kind of doesn't matter. Now, in the meantime, Doug has started work on the application as well, and I go into my test form. I'm going to add another button. Like I said, I'm good at adding buttons, not so good at doing anything with them. Let's generate our text equivalents. Let us commit. Added second button. And I'll press F5 right away so we can see that, yeah, those files got changed. And let's go and do a sync. So we're going to do a pull. And uh-oh, we have a problem. The problem is that changes were made to that form, and Git can't merge changes in binary files. But interestingly, you notice that the SCX and SCT files have a conflict, but the SC2 file doesn't. Let's go and find out why it doesn't. Let's go and take a look at the SC2 file. And you notice that it doesn't show up with that funny little icon. And if we go to tortoise git diff with previous version, we can see here that, I added a button. Tamar added some code to the click method of the first button. Those changes are not mutually exclusive. And because the SC2 file is just a text file, Git merged those changes together because, like I said, they weren't mutually exclusive. So it merged those changes together into the SC2 file. And so it's good. It's got both sets of changes. The only problem that we have is that these two files are in conflict. So we're going to lie to Git, and we're going to say, you know what? I've resolved these changes. I haven't really yet, but I'm going to lie about it and say that I did. Because here's what I'm going to do now. I'm going to regenerate this because the SC2 is now correct. The SCX is not. So let's go into here. We'll go send to Foxbin to PRG text to binary. That's the two-way thing. So I'm going to go from the text file, regenerate the binary files, and let's go back into our project, and let's go and take a look at the form. And you can see that I've got my second command button, but I also have the code that Tamar put into the first command button's click method. So I have got both sets of changes merged together. Okay, so what do we want to do next? Get my notes here. Okay, so let's go into here and let's go and add a message, and we'll say howdy. Generate our text. We'll quit out. And let's go into, let's go and commit it. Oh, sorry, I hadn't committed my earlier change, of course. So this is what's called a merge commit. So because I had made changes to my files, it wants to, I have to commit those changes as well. And every time I try to commit, I'm going to kind of keep on getting this message here, until I take out these hashtags. So just, I could take out all this text altogether, or I could leave that in, whatever. You just can't have those hashtags in there, or I could ignore them. But anyway, so let's go and commit that. Let's see, do I want to do a push? Check my notes here, make sure I get things done in the right order here. Yeah, we're going to do a push. So we'll do a poll. And we're going to, no changes were made by anybody else, we're going to do a push. Okay, now on Tamar's machine, I told her that, we had this merge conflict, I've taken care of it. So she's going to go in here. She's going to do a poll. And you can see the in change list. All those things changed. And she's going to go into the project. Oops, documents. And you can see all the changes are here. Right? Let's go and change this one. Let's go and change this to hello there. Generate our text. Oops. Let's commit those changes. Oops, sorry. Still have it open. Oh, I see what happened. You moved to another machine. Sorry, my other screen. Okay, sorry. Get out of there. Okay, and let's refresh this. Okay, and we'll say that we changed message. Let's commit that. Let's do a poll. Nothing changed. We'll do a push. And we're good. Now, in the meantime, Doug is working away in the project, decides he doesn't like that howdy message in command 1 or testing. What was it in command 1? Yeah. So let's just change that to something else. Generate our text. We're going to commit. Changed button message. We're going to git sync, do a poll, and we have another merge conflict. And this time the SC2, it's not just the SCX and SCT like last time, the SC2 is in conflict as well, because two different changes were made that are incompatible, or they're not, can't both be done at the same time. So if we right click this and choose edit conflicts, this opens Beyond Compare, and it shows you three things. It shows you on the left here what got pulled in from the remote repository. It shows at the right here what exists on my machine, and down here is what the merge would be. So I'm taking a look at these messages here, and maybe we decide that Tamar's is the one that we should keep, because we have to do something, right? We can't, they both can't be there. Something's got to be changed. We have to accept somebody's changes. We could actually put them both in. I mean, maybe if there was 2 lines of code, we could merge the 2 of them together. But in this case, because it's on the same line of code, we have to pick one or the other. So you can choose the left block, you can choose the right block, and so on. I'm going to choose the left block. And down here in the merged area, you can see what the new code will be, even with the typos, which I can actually fix right here. Anyway, so let's go and save that. And now, again, we're going to go here and we're going to say that these are all resolved. But of course, they really aren't. The SCX and SCT are not really resolved. It's the SC2 that is. So again, we're going to go to here. We're going to say send to text to binary. And if we go into the form, you can see that now it's got Tamar's message, not mine. Okay. So again, we're going to go into here and we're going to commit. And again, this is one of those special commits. And so we'll leave the commit message in there showing that, you know, these conflicts were, or you could remove it. Again, up to you what your message is, but anyway, we'll keep that. And then we're going to git sync, again, do a pull, no other changes. We go and do a push. And we let Tamar know that, hey, this, you know, there was a merge conflict, but I've now merged them. And we're done. So Tamar goes and does a pull and close. And now we're both in sync. All right. Any questions about anything of that I've shown?
Yeah, I've got a series of questions. Let's see if I can find them all again. Do you have to recommit after converting text to binary to resolve conflicts?
No, in that case, you don't have, well, you still have to commit. You don't have to regenerate the text equivalent because we use the text equivalent to generate the binary file. But yes, you do need to commit. That's what that special merge commit was. When you have a merge conflict, you do need to do need to commit that so that the updated SCX and SCT files are put into the repository. Otherwise, it was just the SC2 that was the only one that got merged.
Okay, great. Does Foxbin to Prog handle differences in data environments, like a table is in one version of the screen and not the other?
How do you mean a table is not in one version of the screen? I'm not sure I understand that.
I think this is somebody who's putting tables into the data environment of forms.
Oh, I see. Okay, yes. So that is part of the form. So if you add a table to the data environment of form, that would become part of the SC2 file as well.
Okay, and I think there was one more down here. How do you back up from a mistake which you made and have already committed?
I'm not going to get into that because I don't have time. I've got more things to cover. We can maybe talk about that in the Q&A session later on.
Okay. And I think that is everything for now.
Okay. All right. So the next thing is we're going to talk about is branching. Branches are independent lines of work. So in other words, I'm working on feature 1, you're working on feature 2. The idea really is to prevent them from conflicting with each other, whether it's one developer from interfering with another, or maybe I'm working on feature 1, but now I've got a bug in my release version, so I need to go back to the release version and fix the bug so I can re-release it to the customers without losing my feature 1 changes that I was working on. So they're basically independent lines of work that sort of have a common ancestor, but diverge at some point. And then at some point, we're going to want to bring them back together again. So we're going to create branches and we're going to commit to those branches. We'll then merge other branches into each other, or we might use pull requests to do our merges. So let's go and take a look at some examples of those. So Doug is going to be working on feature 1. So I'm going to go tortoise git, create branch, feature 1, I'm creating a branch for it, and I'm going to turn on, which is already on for me by default, switch to that new branch. Okay, so now I'm working with branch number, feature number 1. Tamar, in the meantime, is also going to be working on a new feature, but different than mine. So she's going to be working on feature 2. We want that to be the new branch. Okay, so now Doug is working away, and I'm referring to myself in the third person here. I'm going to go and into that form, and I'm going to add yet another button. Really good at adding buttons, not so good at doing much with them. And let's go and generate the text for that and quit. And now when I go and right click and notice it says git commit to feature 1. Before it said git to commit to main. Main was the default branch. That's the one that we were working on before. However, now we've switched to feature 1, and that's the branch that we're going to commit to. If you want to commit to a different branch, you can, but the default is that it's going to commit to this branch. So we'll go in here and we'll say added third button. and we'll commit that. And I can go here and I can say, I actually don't have to do a pull. I can do a push because I'm not, nobody else is working on feature one branch. And so we'll just go and push that feature one branch. And in fact, now if I go to GitHub and refresh, you'll see a couple of things. One is that there are now two branches. There's main and there's feature one. And we also see a note here that their feature one had a recent push and we could do a pull request if we wanted to here. Now, in the meantime, Tamar is also working on the application, and as part of her change, she's going to add a new program. So let's create a new program here. And we'll call it test. And because we just changed the project, right? That was we added new field to the project. We should generate, even though the text file is not the program is as a text file, but the project itself got changed. So we generated the text for that. One other thing we have to remember to do, and this is easy to forget, but when you add new files to your project, you got to remember to add them. So although they would show up, if I were to just go here and say commit right away, we would see it right here. Oh, right, test, I forgot about that one. I can actually go and add it right now rather than having to go and add it separately. But anyway, so we added program. And let's go to commit that. And we'll go and do a commit, we'll go and do a push. And if we go back to Tortoise Git, or sorry, back to go back to GitHub here and refresh, we can see that there are now three branches: main, feature one, and feature two, and that these other things are there. How am I doing for time? Okay, I still have a little bit of time left. All right, so let's go and do another change here. We'll do it. Well, sorry. One other thing I need to do is, so let's say now that Tamar, that program that Tamar just wrote, I actually need that. She's done it as part of another branch, but I actually need that test.prg for some work that I'm doing. So what I'm going to do is I'm going to go here. I want to merge those branches together, merge the changes. So I'm going to go and switch to the main branch. Did I merge those yet? Yeah, I'm going to switch to the main branch. Sorry, yeah. Check my notes here, make sure I got what I need here. Okay, so get a pull request. Oh, I didn't merge them, right? Okay, yeah, I thought I was missing something. Okay, so let's go back to here. Go back to GitHub here. Oops, go back to GitHub there. Come on. GitHub. Why is it not doing? Why is it not staying? Here we go. Okay. So I'm going to go in here and I'm going to do a pull request. And I'm going to create the pull request. I could add a message if I wanted to about that. And here, when you do a pull request, you can actually have a conversation. So for example, the person who would merge the pull request can say, hey, I don't understand what change you made. And then the other person can respond, oh, well, it's for this. And you can have a conversation that goes back and forth. You can keep on adding comments until finally the person is satisfied. They can check to see what files were changed. Here are the files that were changed in that pull request, and so on, until finally they're like, okay, yeah, I'm ready. I'm going to go and merge that pull request. And we're all done. There aren't any open pull requests, but we could create another pull request for that feature branch too. And we're going to resolve the conflicts because there's this PJT. I'm just going to mark it as resolved. And we're going to do the commit. And now we're going to do our merge our pull request. And we'll confirm that. Okay, so now we have no more pull requests. And all of those branches have been merged into main. So now I need, because I'm still sitting on branch one, you notice there's no test.prg. So what I'm going to do is on my machine, I'm going to go to Tortoise Git. I'm going to switch to the main branch. And you notice that we still don't have it yet, but we're getting there. So now I'm going to do a poll. Okay. And now we can see test.brg is there because we're on the main branch. But watch what happens when I switch back to my feature one branch. Oops. Feature one branch. Come on. Feature one branch. There we go. Okay. Test.prg is gone. What the heck? Well, that's because I haven't merged them yet. So let's go and do that. You always merge into. That's why we have to choose our feature one branch. And we're going to merge from main. Okay, so sorry, I chose switch. Try that again. Tortoise Git, merge. There we go. Merge from main into feature one. And now, if we take a look, the project. Oops. Oh yeah, that's fine. Because that PJT got a little. I made a mistake along the way, and I didn't do something quite right, but that's okay because we can always do this. And now I can go into my project, and you'll notice that we now have the test.prg change that Tamar made, as well as that third button change that I made. And we can do the same thing on Tamar. So on Tamar's machine, we will switch to main. We will, oh, and by the way, you notice that test.prg is gone, right? We haven't merged them yet. So we haven't done a pull yet. So now we'll do a pull. And now we're going to switch back to our normal branch that we work on, feature two. And we're going to merge from main into feature two. And now if we go into here, oh, you know what? I don't think I pushed from my Doug machine yet. Let's check that. Do I have the third button? Oops. Oh yeah, same deal here. Sorry, I got to fix that. Okay, so we have all three buttons. We have that third button that Doug added, and we have the program that Tamar added. Okay, so we now are back in sync again. We're still on different branches, right? I'm still working on feature one. Oops. Tamar is still working on feature two, but we've now merged the changes together because she needed some changes that I made, and I needed some changes that she made, and so on. Any questions about any of that? We'll have to keep it short because I'm starting around time. I have a little bit more to cover yet.
I don't think there's anything.
Okay. All right, now I've been doing it all through Tortoise Git. So right click this and right click that. And Tortoise Git works great for a lot of those simple things like commits and pulls and pushes. More complex things, it's better to use a better GUI. Tortoise Git does have a GUI. It does have, you can view the repository and you could look at branches, stuff like that. It kind of sucks. The UI part of Tortoise Git really kind of sucks. So we're going to use source tree instead. It has a much better UI, especially for things like history and searches and file status and things like that. Some people use source tree as their sole GUI or their sole UI for Git. I tend to bounce back and forth. I use Tortoise Git for some things, and I use source tree for others. So it's kind of whatever development pattern you want. So anyway, let's fire up source tree. And if we go and take a look at the history, you can see here is the history of everything. Here's the initial commit. And then here's when I added the text equivalents. And here's when I added text ignore and so on. And then at some point, Tamar started working on things. You'll notice it shows Doug as the author for all of them. That's because I'm just one person working on one machine. But in reality, we would see Doug for some things and Tamar for other things and so on. And we can see that by these little train track kind of things that, which branches were used and what changes were made and were merged and so on. We can go and make a change now. Let's go back to our application. Let's go back into here. And let's go and make one last change. And this really isn't a cool application. It's a pretty lame application. So we'll just take out the word cool. And let's go back to source tree. And if we go to file status, we can see that main.prg was changed. We can see exactly what the change was here. These two changed as well. That's because they were those binary file changes. So these are unstaged. So I want to tell source tree that I intend to commit these. So let's go and stage them. And then I can put a commit message down here that I removed the cool. And then I can go and commit that. Okay, so that got committed to my feature one branch. You can see that it was feature one branch. I can do pulls, I can do pushes. I could push this out, for example. And now that's been pushed out. I can do searches. So if I go to search here, for example, let's search for anything that had the word button somewhere in the commit message. So I can choose what I want to search. So commit messages. So these are all the commits that had changes that had the word button somewhere in the commit message. So I can go and see, well, what files were changed on this commit? Well, the SCEX and here's the, here's the change that was made. I could also search, for example, for file changes. Let's look for the word command somewhere in a file change. Well, here in this one here, you can see that the word command appeared in one of the file changes because I added a command1.click method to this form. So source tree is a really nice UI. It's free, really nice UI that you can use to work with Git. And like I said, if you want to use this you can do everything in Git that I was showing in TortoiseGit. You can do clones, you can do branches, you can do merges, pushes, pulls, commits, and everything. So you may choose to use source tree for everything. Like I said, I started using TortoiseGit, and so I'm kind of in the habit of doing it with the right click. But whatever mechanism you want to work with, feel free. That's, work however you see fit. Any questions about that?
Nope.
All right, well, let's wind up. Version control is essential for modern professional development. And not just for multi-team development. I mean, it's kind of like a no-brainer for that. It would be extremely difficult to work in a multi-developer environment without using version control. But even in a single developer environment, Git has saved my bacon a number of times where I, made some change and oops, that was dumb, and now I need to go back to a previous version and restore those changes. It's not hard to get started. The white paper has pretty much a step-by-step instructions for what you need to do to get going. And I promise you that once you've used version control in your application development toolkit, you'll never go back. There are times when I'm working on things that are not software development, but just working on files, and I think, oh, I got to commit this, and oh, that's right, we're not using that for this, Word document or something like that. All right, last chance for any questions.
No questions, but I want to take this opportunity to thank everybody for their patience while we were sorting out technical stuff and for our on-the-fly schedule change. The plan is that we are going to push the last two sessions back 15 minutes each. So Rick Borup's problem seems sorted out, and he's going to go at 4:15, and then 4:15 Eastern, and then John Ryan will speak at 5:45 Eastern.
All right, well, thank you, everybody. Please fill out your evaluations, and I'll see you over in the Q&A room.